Welcome to the 12th of 14 videos on the Arc Flash Truth No One Explains. My name is Joe Chacon. I'm the president of Podge LLC and Chacon Engineering. I'm a licensed professional engineer in multiple states and have been an electrical engineer for almost 30 years. Please like and subscribe as this helps us get this important information in front of more people. This video is going to address how Arc Flash can be reduced or remediated. This is definitely my favorite video and one of my favorite topics to discuss with my customers. There is a myth that arc flash remediation is cost prohibitive. I hope to dispel that myth in this video and give you some practical ways you can do this with engineering controls and administrative controls. So let's look at engineering controls first because that falls into the higher tier category of OSHA's hierarchy of controls. Let's look at engineering control number one. One of the easiest ways to do this is with remote switching. You can have an undervoltage coil, shunt trip coil, or an electronic trip solenoid. There are pros and cons to each one of those types of ways of tripping. These enable you to remotely operate the switching device. Some of you are thinking ahead and saying, Joe, we still have to do a live absence of voltage verification step, and we must assume it is still energized until that's done. If you thought that or said that, then you're one of my favorite types of customers, a very smart customer. Therefore, to complement remote switching, you should also install a remote presence of voltage verification test port. You can do this for about $2,000 extra on your project. A retrofit for an existing installation is not that much more. Engineering control 2. The service entrance is one of the highest incident energy areas of any electrical installation. This is often because many people defer from putting an overcurrent protective device between the service entrance transformer and the service entrance. Renewable energy is one of the worst offenders of this. Recall, in all the equations for incident energy that we examine, we want to reduce arcing current and/or clearing time. A pad mount transformer will allow massive amounts of fault current on the secondary before the primary devices clear it. Secondary breakers or fuses will limit this and often take 200 to 400 calories per centimeter squared down to 30 to 40 calories per centimeter squared. You can do this for about $3,000 to $15,000 extra on your project. A retrofit is probably $5,000 to $20,000. Engineering control 3. Current limiting devices. In our last video, we examined current limiting fuses. I like those because they are inexpensive and do a fair job at reducing both clearing times and fault current. A current limiting reactor is a quasi-expensive way to reduce fault current. There could be a time and place for this solution. As an example, suppose you have a 600 volt system with 50,000 amps of fault current. You elect to put in a 9 microhenry current limiting reactor. Your 50 kA goes down to 33.6 kA. This particular example could actually save you some money because you can now use 35 KAIC breakers, which are less expensive than 65 KAIC breakers. Engineering control number 4. Arc resistant gear. Our next video will be about this topic in its entirety, but I wanted to mention it here as the top of the line premium engineering control. It is also probably the most expensive. These engineering controls are obviously not exhaustive, but meant to get you thinking about practical and inexpensive ways to keep people safe by reducing incident energy. Now let's look at some administrative controls. I stress that these are ghastly inferior to the engineering controls. Administrative control number 1, maintenance mode settings. Many relay and breaker manufacturers offer the ability to have settings for maintenance mode. These settings do not reduce the fault current, but they do reduce the clearing time. The big gotcha on these is you still have to wait about 3 cycles for a breaker to operate. A fuse can get that down to a half a cycle. Administrative control number 2, work further away. Use a hot stick. Use a portable remote switch operator. I've heard people call that a chicken switch, but I believe that's an official brand name. Consider a shepherd's crook. I consider that more of PPE, which is even more frowned upon in terms of hierarchy of controls. Consider test probe extenders for your volt ohm meter. Here is the big gotcha for all of these. You need a professional engineer to tell you what the incident energy is at this new working distance. We do this for our clients and would love to help you with this calculation. I hope this video gave you some practical things to think about with respect to incident energy and help dispel the myth that it's too expensive. We'd love to help you take these insights into practice for your company. The next video is going to be arc resistant gear. We're going to talk about arc resistant gear. I'm also very passionate about that